So yesterday we were working on different types of vocabulary words that you would see in Math 1. So I'm going to review that and then we'll finish out these notes, okay? That way you can do the worksheet fairly easily, okay? So we talked about an expression, and remember an expression are the ones where you just have like numbers and variables, and then you have to have some type of operation going on, like adding, subtracting, multiplying, or dividing. And so these were all expressions. Then we talked about three different things that they might ask you about in terms of an expression. So the first thing is what a term is. And so the big thing that I talked about was, remember, terms are separated by your plus and minus signs. And so if you remember that, it made it very easy to kind of figure out what your terms were. So think about them like walls. They're separating your terms in a way, okay? The last two things that we talked about was a coefficient and a constant. So remember, coefficient is the number that's in front of the variable. So that would be like your 4 and your 3 here. And then a constant is the number that doesn't have a variable. It's kind of by itself. So that was like -2. All right. And then I gave you an example. And so let's just kind of go over this and make sure everybody's together. So like with this example, if I had to figure out what the terms were, well, I'm going to look at my plus and minus signs, and I'm going to think about them like walls. So one of my terms would be 4x squared, and I'm going to put a comma. Another term would be, because there's a minus sign right there, it goes with the thing that it's in front of, so it'd be a -5x. That would be the next term. And then 3, I'll have to just write it down here, would be the last term, and it's a +3, so I could just write it as a 3. The coefficients, remember, these are the numbers that are in front of your variables. So my coefficients here, well, there's a 4 in front of a variable, so 4 would be a coefficient. And let's see, there's a variable here, so the number in front of that would also be a coefficient. So -5 would also be a coefficient, okay? And this is a little and symbol. It's kind of hard to see. All right, and then the constant, remember, the constants are the numbers that do not have a variable with them. So they're kind of by themselves. So in this problem, 3 would be a constant, okay? So before we move on to the last little bit of this side of the notes, I want to talk about this right here because we kind of skipped over it. So in this class, you're going to see sometimes they describe things as an expression and sometimes they describe it as an equation. And so I need you to know the difference. So what we've been working on so far in these notes is what are called expressions, okay? And so expressions are just going to have terms to them. So it's going to have the numbers and the variables, and you're going to have like plus and minus signs sometimes. So like 5x plus 7 would be an expression. Okay, or if you had like 2x squared minus 4x plus 2, that's an expression, all right? And so these are expressions. It just has terms to it. But sometimes in some problems you're going to see what are called equations. And so if you kind of look at the root word here, like that part right there, it kind of makes you think, hopefully, equal, about the word equal. And that actually has a lot to do with what makes an equation. So for you to know, just by looking at something, if it's an equation or not, what you're going to actually look for an equal sign in it. Because an equation is going to have terms, so you're going to see something like this, but you're also going to see an equal sign in there somewhere. And so if it has an equal sign, then that means it's going to be an equation. So I can actually take this, like if I take the 5x plus 7 and I put equals -3, that you would call an equation, not an expression, because now you have an equal sign in there, okay? Same thing if I, for instance, took that one, 2x squared minus 4x plus 2 equals 0. That is an equation now because you have an equal sign, okay? So now one big thing when you're dealing with expressions or equations, the directions that they give you will be different. So like when you're dealing with an expression, what they're going to tell you to do is to simplify the problem, because that's the most you're going to be able to do, is to simplify it. When you have an equation, you're actually going to be able to solve the equation. And remember, when they tell you to solve something, what they're telling you to do is to get the variable, whatever the variable is, by itself. So let's write that down. So get the variable by itself. Okay? And so, like if we had an x, what I mean by that is you would have x on one side of the equal sign, and then you have the equals, and then it'd be equal to some number. Okay, so that's what it would look like in the end if you were solving it. So that's going to be something that is kind of helpful as we move forward in this class, because if they tell you to write an expression, you're writing something that looks like this. If they tell you to solve the equation or set up an equation, it's going to look like this. It's going to have an equal sign in it, okay? So that's something that's good to know, all right? So let's talk about now more with expressions, all right? So these are some other terms that you might see as we move forward. And then the first term that we're going to talk about, sorry, my camera keeps moving here. The first term we're going to talk about is what's called a polynomial. So we're going to actually break this word into parts. So the word poly, it can be thought of as like many. And then the prefix nomial is actually talking about the terms. So if you kind of put that together, this kind of translates to it's going to have many terms to it. And so remember, your terms are separated by your plus and minus signs. And so a polynomial is just going to be something that has terms, all right? Now, you can actually break that down even more. So you can have what are called monomials, binomials, trinomials, and it could go up from there, but these are the ones that you're going to see most often, okay? So a monomial, if you look at the prefix mono, that means one. Then a monomial is going to have one term to it. So like an example of that would be if I just, for instance, take one of these terms that I was dealing with yesterday and I just wrote one of the terms down, that would be a monomial. So if that's, for instance, take that 4x, and that's the only thing that we had there, that would be called a monomial. Or, for instance, if I took, I don't know, like this term right here, 4x squared, and or actually, let's change that. Let's make it like a 5x squared, so it's a little different. If I had something like that, notice that's just one term because there's no plus or minus signs. So that would be classified as a monomial, okay? A binomial, well, the prefix bi means two. So a binomial is going to have two terms. So if I, for instance, take two terms and I have like a plus or minus sign between them, that would be a binomial. So let's say that we take these two terms, 5x squared and then plus 4x. If I put them as one thing and put a plus or minus between them, that is now a binomial. Okay, another example, just to have another example, what if we had something like 10y minus 8? That is what's called a binomial, because you have the 10y and then you have the negative 8. That's two terms. So then, trinomial, you probably get the gist now. Tri means three. So a trinomial has three terms to it, okay? So a trinomial, you have to have three terms. So like an example of that would be if you had 4x squared minus 5x plus 3. That has the 4x squared, the negative 5x, and the 3. That has three terms to it, okay? Another example that is starting to get into the problems that might look a little harder would be, let's say if you had something like this, x squared y, yay math, right, plus xy minus 4. Let's say you had something like that. That is actually a trinomial because, remember, your plus and minus signs are what separate your terms. So this would technically be a term. The positive 1, that's like a 1 right there. Remember, if there's nothing in front of a variable, it's technically a 1 in front. So that would technically be a term, and then the negative 4 would be a term. So that is actually a trinomial. Okay, and so those are some terms that you might see off and on, okay? And so when you're dealing with expressions, they're often going to tell you to put them in what's called standard form. So we're going to talk about what is standard form. Standard form is when you take your terms and you list them from the biggest degree to the least or the smallest degree term. Okay, so what do we mean when we say degree? Degree is talking about like the exponents of the terms. And now we're going to get a little bit more specific in a minute, but for right now you need to think the degree is wanting you to look at the exponents. So we're going to actually start out with an example here. All right, so I'm going to just put a little 1 for the first example. Let's say that they give you 3x plus 2 minus 4x squared as your expression. Okay, they will tell you to put that in standard form. So what they're telling you, and you're actually going to always want to put these in standard form, so you're going to have to get practice with it. But they're going to tell you if they tell you to put it in standard form, you're going to list it with the one that has the biggest degree all the way to the one that has the smallest degree. So you're going to look at the exponents of each to know what the degrees are. So there's the 3x, that's a term. You've got the 2, and then you have the negative 4x squared. Those are your 3 terms. You're going to look at them one at a time. So I'm going to look at the 3x, and I'm going to say, okay, look at the variable and look at the exponent that's with it. Now, if it doesn't have a variable, if it doesn't have an exponent with the variable, then the exponent is technically 1, okay? So the degree of this one is whatever the exponent is that's with the variable. So the degree of this term would be 1. This one, notice it doesn't have a variable at all. So if it doesn't have a variable at all, the degree is actually 0 because it doesn't have a variable, okay? This one, notice we do see it has the exponent with it. So the degree is whatever that exponent is. So the degree of this one would be 2, okay? So when you list them from highest degree, or you're putting it in a standard form, so when you do that, you list it from highest degree term all the way to the lowest one. So this one had a degree of 1, that one had a degree of 0, that one had a degree of 2. Which one's the biggest one? That one is the one that goes first. So if you kind of think through it, this one was the one that had the highest degree. So that term, we take that entire term and the sign, remember, goes with it, that's in front of it, and we put that first. So that would be the term that goes first. Then whichever one has the next highest degree goes next. So this one had a degree of 1, so that's the next highest one. And it's a positive 3, so remember you have to put your signs to separate them. So you put plus 3x. And then that 2 was the lowest degree, so it goes last. So that is now in standard form, okay? So whenever you put it in standard form, there's actually a couple other things they can ask you about. They can ask you what is the degree of the polynomial as a whole. And so what they're asking you when they ask you that is which, like out of all of your terms, what was the highest degree that you had? So like if I ask you what is the degree, I'm going to shorten it, of this polynomial, I'm looking for the term that had the highest degree, and whatever the degree is there is the degree of the polynomial. So this one had a degree of 2, that one had a degree of 1, and that one had a degree of 0. So which one was the biggest degree? Well, that was this one right here, and the degree was 2. So then the degree of the polynomial is 2. It's the greatest degree of its terms. Like out of all of its terms, it's the one that had the greatest degree. So the degree, the highest degree we had was 2. Okay. Another question they could ask you what is the leading coefficient? So it says when you write the polynomial in standard form, so that means you have to put it in standard form first, it is the coefficient of the first term. So when it's in standard form, it's the number, because remember coefficient is the number in front of the variable. So it's the number that's in front of the first term. So if I look at this polynomial, it's already in standard form. We've already done that part. So if they ask me for the leading coefficient, I'm going to look at the coefficient that's in front of the first term. So this is my first term. The coefficient in front is -4. So the leading coefficient is -4. Okay? So let's do another example here. Let's say that you had something like x to the third plus 5x to the fourth minus 2. Okay? So if we had to, we're going to do all three of these things. If we had to put it in standard form, the first thing that we do is we find the degree of each. So remember, the degree is the exponent. So the degree here would be 3. For this one, the exponent is 4. And then this one doesn't have a variable, so remember the degree would be 0. And then we're going to list them from the highest degree term to the lowest one. So the one that had the biggest degree was this, so that's going to go first. You put the entire thing first. Then the next biggest one was the x to the third, and remember, if it doesn't have a number up front, that's technically a 1 right there. Okay, so it'd be plus technically 1x to the third, but we just write it as x to the third. And then the minus 2 comes down. So now it's in standard form. They might ask you these questions. So if they ask you, what is the degree of the polynomial? Go back and look at what the degree of the polynomial is. It's the greatest degree out of all of its terms. So if I look at the degrees of each one of these again, I'm going to look for the one that had the biggest degree, which was this one. The degree of that was 4. So then the degree of the polynomial is 4, because that was the highest degree it had. If they ask you what is the leading coefficient for that one, so I'll abbreviate again. So the leading coefficient would be, after you put it in standard form, so make sure it's in standard form, it's the number that's in front of, it's the one that's leading, right? That's why it's called leading coefficient. So it's the number that's in front. So the leading coefficient would be 5. Okay? So that is how you put things in standard form, and then that's how you kind of describe those different things. All right? So now the last thing we're going to talk about is combining like terms. And in order to combine like terms, you have to remember and know how to tell if two terms are what are called like terms. So that's actually where we're going to start here. Okay? So the way that I kind of describe it has been very helpful for people. So I'm going to talk to you about how I think about like terms. All right? So like terms are the terms with what I call the same last name. Okay, so let me describe what I mean by that. So let me take like a term up here. Let's take the 5x to the fourth. So if I'm looking at that term right there, okay, I actually kind of think about it in two ways, all right? And that 4 is an exponent. I know it kind of looks weird, but it's an exponent, all right? I kind of look at the number up front, that, the coefficient, in other words, that I consider to be like the first name of that term. So that 5 is what I call the first name. And then anything that's after that is what actually I consider to be the last name. The last name. Okay? So, in other words, this x to the fourth, I think about as the last name of that term. So, if I put another term up here, like let's say that I have 5x to the fourth, and I'm trying to figure out, can I combine that? So like combine means add or subtract. So can I combine that with, for instance, like 6x to the third? Well, I'm going to look at the last names of those terms, and I'm going to ask myself, do they have the same exact, I mean, everything has to be the same exact last name, okay? Well, we just talked about this one. The 5 would be the first name. So I'm not really looking at that right now. What I'm looking at is everything that's behind that. So I'm looking at this part right here, and I'm going to ask myself, does this have the exact same last name as the last name of this one? So if you think about this, 6 would be like the first part of it, or the first name, and then everything after that would be its last name. Are those two things exactly the same? Is x to the fourth exactly the same as x to the third? And no, they're not, because that has a 4 and that has a 3, right? That's not exactly the same. So because of that, I would not actually be able to combine these. So, and the reason for that is because they don't have the same last name. They don't have the same last name. So if I asked you to simplify this, you would actually have to leave it exactly the way it is, because you couldn't do anything with those. So that would actually be as simplified as it gets, okay? So then what if you had something like this? What if you had, for instance, 2x to the second power plus 4x to the second power? And you had to combine those. Well, you're going to do the same thing you did here. So look at the first and last names, and you're going to check, are the last names the same? Okay, so the first name here is 2, and the last name is x squared. And then the first name here would be 4, and then the last name would be x squared. Are the last names exactly the same? If they are, you can combine them. If not, then you won't be able to combine them. And notice, x squared is exactly the same as x squared. So you would be able to combine them. So if you can combine them, I'm going to go ahead and talk about what you would do. If you can combine them, then whatever their numbers are up front, you're going to combine like normal numbers. So like combine, you're going to add or subtract, and there's a plus sign between them. So that means you're going to add them. So it'd be 2 plus 4. So 2 plus 4 is 6. And then after you combine them, whatever the last name is will actually stay exactly the way it is. So like think about when two people get married, usually one will take the name of the other one, so they have the same last name. It's similar to that idea. So whatever the last name is going to just come down. So it's going to still be just x squared. All right. So when you combine these, you get 6x squared. All right. So now that you know kind of how to tell if two terms are like terms, now we could actually write the steps down to be able to combine like terms. So the first thing that we did is we found out if they were actually like terms. So you're going to find the like terms to begin with. So find the like terms. Okay. And then after you figure out which ones are the like terms, then you are going to, like we did over on our example, you're going to add or combine the coefficients. So it depends if you're adding or subtracting, but you're going to combine them. So coefficients, which are the numbers up front. And then you keep the last name the same. So you keep the last name the same. I'm going to run into the other part. So let me put a little dividing line. Name the same. Okay, so we're going to flip over, and I'm going to just show you some of these examples so that you can kind of just have some examples to look at if you needed to, and then you'll be able to work on the homework. All right, so I'm going to flip this over. All right, so one thing that I want you to realize is the word combining, and I've been saying this, whenever you see the word combining, what that means is you're either adding or subtracting things. Combining is just those two things. Multiplying and dividing are actually different, and so there's different rules with that, and so just know when you're combining like terms, you're just adding and subtracting them. Okay, so if we look at these examples right here, you'll notice that to combine these two, so this was our problem, I noticed that 5x and positive 8x had the same last name. So I combined those. So 5 plus 8 got 13, and then notice the x just kind of came over. It stayed the same. And then that 2y was not a like term, so it just was brought over. Here, let's see, the 5x squared and then the positive 2x squared were like terms. And then these two were not a like term with anything. So notice those just came over. And usually they'll put them in alphabetical order. So that's why they put the 8x first, because x came before y. And then when they combined these, they had 2 plus 5, which was 7. And then the last name stayed the way it is. Okay. So let's work through some of these. So if I was doing this, I'm going to identify the like terms first, okay? So 10x is a like term with 5x, so those are going to combine. And then that 3y doesn't have a like term or a same last name as anything, so it's just going to come over. So we got 10x plus 5x, which is 15. And then remember, the last name stays the way it is. And then that plus 3y just comes over. So there we go. Number 2, find out your like terms. So this 2x squared has a last name of x squared, and then this one also has a last name of x squared. So notice how I circled the sign that's in front of it. That's important. So those two are going to combine. These two, it has an x, but notice it's not an x squared, so that makes it different. All right. So these two are just going to come over because they're not like terms with anything. And so if we were having to put this in standard form, because remember, we always want to list it from highest degree to lowest, the 2 has the highest degree, so we have to put that one first. So let's go ahead and combine these. We got 2 plus 6, which is 8, and then the last name just comes over. And then these two don't have anything to combine with, but like I talked about up here, we usually put them in alphabetical order, so I'm going to put the plus 4x first, and then plus 7y. Okay? Oh, sorry, you guys can't see that. All right, so I'm just going to kind of work through the rest of these, and that way you'll have the answers. If you want to pause it and give it a go and see if you're good with them, you can do that, and then check your answers. But just make sure that you're kind of getting these down so that you have extra examples, all right? So with this one, the non-C and the 3C are like terms, so that one and that one are going to combine, and then that 5A has a different last name. And so when I put it in... when I put my answer, notice A comes before C in the alphabet. So 5A is going to go first, and then I combine these. So 9 plus 3 is 12. So that'd be plus 12, and then the last name stays the same. This one, I noticed that 2y squared, 2y squared and 6y squared are like terms, and then actually the 7y and the 4y are like terms, all right? So if I put it in standard form, I'm going to do this one first, which you should always be putting it in standard form, because it has the higher degree. So 2 plus 6 is 8, and then the y squared comes over. And then 7y plus 4y, I get 11, and then the y comes over, all right? This next one, the 8x and the negative 2x are like terms, and then that y is not a like term. So I'm going to combine these first. So 8 minus 2, so this is why the signs are important to circle with them. 8 minus 2 is 6, and then the x, the last name stays the same, and then that plus y comes over. This one, the x squared, which remember the number in front when it doesn't have 1 is like a 1, so that's like a 1x squared, plus the 9x squared, those will combine. And then actually this 7y minus 4y, those are like terms as well. So we're going to do the x squareds first. So 1x squared plus 9x squared is 10x squared. 7y minus 4y is plus 3y. Okay, and then that's it, because that's everything. The next one, we actually have a bunch of stuff going on. Notice this 14x has a last name that's the same as this one and that one. So all three of those will combine. And then this 2y minus y also are like terms, okay? So let's do the x first. There's a couple ways you could do this one. You could take 14x minus 3x and figure out what that is, and then add 3x, and then you'll get it. Or if you notice, if you kind of look ahead, if I have negative 3x plus 3x, negative 3 plus 3 is 0. So those actually cancel out. And so if you recognize that, you can just cancel them out, all right? If not, it'll still give you the same answer, okay? So then I'm just left with 14x, and then 2y minus, this is like a 1y right there. So 2 minus 1 is 1. So, and it's a positive 1, so I just write plus 1y, which is the same thing as just plus y. This next one, The only like terms that I have are actually this one and this one. These don't have the same variable. So remember, if they don't have the same exact last name, then those are not like terms, okay? So we're going to combine those, but when we write our answer, we're actually going to have to put these first to put it in standard form. So alphabetically, the 5x squared will come first. Then I'll put the 5y squared. And then 5y plus 5y is plus 10y. So there wasn't a whole lot that combined there, just those two middle things, okay? So last two, think about last names. The number up front is the first name. Anything behind that is a last name. So like this one would actually have the same last name as that one, okay? And that 3h will just come over. So we're going to combine these, 23 minus 5. So I get 18, and then remember the last name just comes over, so the mn just comes over. And then I have plus 3h. All right, last one. So this one right here, the last name is z squared. This one also has the last name of z squared, so those will combine. So let's see, 18 plus 6, we get 24z squared. And then the 3y plus z, those are not like terms, so I don't know why I did that. I'm sorry. Those won't combine, and so I'm just going to bring them over. So then we have plus 3y plus z. So there we go. All right, so hopefully this helps. So now you're going to do the combining like terms worksheet. So let me know if you have questions, and enjoy your day.